Hello out there to you. In this video, let's think about a couple of spending multiplier type and tax multiplier type macro questions. This is a lot of modeling basically, so let's draw a model here. Okay, and for the first one, I guess we're really doing the same thing with the second one, but the second one's just pure math. So we're going to draw out our little aggregate supply, aggregate demand model. And it says here, full employment level is 1,000. So full employment, what does that mean? That means that's the upper limit on what an economy can produce. So we're going to draw a straight line right there. And this is the limit of what this economy can produce, and it's telling us that that is 1,000. This is full employment. Make that a little bigger. Employment. It's also equal to the long run aggregate supply, sometimes called potential GDP also. Same thing. All of that stuff is. Okay, and it says full employment output price rather is 100. So come on over here. This axis, we should label that. That's price level. This is real output here. I'm going to call it Y. And it says, okay, so we're right there. This economy's current level is 1,100. So we're somewhere over here. Okay, so we're 1100. That's where we're at currently. And at a price level of 100, there's this point right here. The aggregate demand is 1,200. Okay, so that means that aggregate demand is currently right there, and we want aggregate demand to shift to the left. Okay, and in this case, we're going to do this by decreasing government purchases. This is aggregate demand. Okay, now when we do that, it's going to eliminate jobs, and that's going to eliminate consumer spending. It's going to eliminate investment. It'll eliminate other government spending too. So by decreasing by 50, we're going to multiply that by the spending multiplier, whatever that happens to be. So to consider this, we're shifting from here to here. Oops. Okay, so shifting from here to here is a shift from, we need to shift the whole thing. So even though we are here, we want to shift the whole aggregate demand. So we need to shift the whole aggregate demand by the difference here, which is 200. So the setup here is the same as other problems. It's the change in aggregate demand equals the spending multiplier times the change in government spending. Or if you wanted to use tax policy, it's the change in aggregate demand equals the tax multiplier times the change in taxes. This is delta is change. Okay, so let's just fill in what we know. We know that we want to shift aggregate demand by 200, so we want this to decrease by 200. We do not know the spending multiplier, but we do know that the government purchases are going to decrease by 50. Okay, so it's 50 times SM, which is the spending multiplier. Spending multiplier has got to be, you can figure that out really easily. All right, or if we wanted to use the tax multiplier, we come over here and, well, I guess we're decreasing government. So if I wanted to get the same amount there, and actually no, I guess you wouldn't use it the way this is phrased, but if you wanted to decrease aggregate demand by 200, I need to know what the marginal propensity to consume is, the marginal propensity to save. And I actually do know that. And because the spending multiplier is 4, I know that this is 1 over 1/4 for the spending multiplier. I guess I did that in kind of a weird way. The spending multiplier, 1 over the MPS. So that means this has to be 1 over 1/4. And so this is 1/4. and this is 3/4. Or you could say 0.75 and you could say 0.25. So the tax multiplier, I just intuitively know that it's 1 minus the spending multiplier because that's how it works. But if you wanted the tax multiplier, we'll actually use that on this one, is negative MPC over MPS. Okay, so in this case, it would be negative 3/4 over 1/4. And so that would be 3. So the tax multiplier would be 3. Change in taxes divides both sides by 3. I don't actually, it's like 60 something, somewhere in there. Come on, calculator. All right, 200 divided by 3, yeah, 66. And so I'd have to increase taxes by 66 2/3. And that would give me the same result. Okay. All right. Next, if the MPC is 0.6, the government could shift aggregate demand rightward. So rightward is an increase. We're going to use the same formula as we used up here. So it's the change in aggregate demand equals spending multiplier times government spending, or rather the change in government spending, or change in aggregate demand equals the tax multiplier times the change in taxes. So in this case, 30 billion, I want this to be plus 30. I do actually know spending multiplier. So the MPS is 0.4 because this and this have to equal to 1. So it's 1 over 0.4, which is actually 2.5, but I'm just going to check here really quick. Yep, 2.5. Change in government spending is 30 over 2.5, which is 12. So if I increase government spending by $12 billion, I'll get $30 billion worth of economic growth. And this works on the principle of the spending multiplier, right? If government spends money here, government spends money here, other people spend money here, other people spend money here, and pretty soon you get more spending throughout the system. All right, so then let's do the tax multiplier. You can use this, or we could just quickly say, well, if the spending multiplier was 2.5, then I know that the tax multiplier is 1.5 and it's negative. So multiply that by the change in T and a positive 30 billion. So the change in T has to be negative. So change in T is going to be negative, probably 15. 20. That's wrong. Wrong off the top of my head. All right, so you cut taxes by 30 billion. You get the same result. Notice the tax cut has to be higher than the spending increase. That's how to work through those kinds of problems.